Hello Year 12 and welcome to the first video for the energy and electricity component of the resources focus study. First of all, we need to learn what a watt is, and how that relates to our electricity consumption. Now, a watt is how much power you need to make something work. Right? To make your microwave operate, your blender or your air conditioner or your fridge, right? It's how much power is required to make that change from sort of not operating to operating. How much energy we're using is different to power. How much energy we use is how many watts in what length of time. Okay, so to work out our energy consumption, our energy as opposed to power, our energy consumption is the number of watts multiplied by the length of time. Now, typically, most appliances are rated in watts, but our energy consumption is mostly measured in kilowatt hours. So a kilowatt is 1,000 watts. So to calculate our energy consumption for an appliance or something like this, we need to convert probably our rating, our power rating, into kilowatts by dividing the watts by 1,000 and multiply that by the number of hours it operates. Now this is going to cover a couple of exercises here. So I've got an example here. Let's say Maurice uses an average of 8 kilowatt hours per day and is charged 30 cents per kilowatt hour. What is the cost per week of Maurice's electricity usage? Right. Well, 8 kilowatt hours per day, 30 cents per kilowatt hour. So that means each day I've got 8 times 0.3 is $2.40 per day, and $2.40 by 7 days a week is $16.80, I reckon. Okay, so that's, they're reasonable sort of figures, I suppose, about $16.80. Now, let's move along here. We're going to push into exercise 1202 because really much of that exercise is about reading bills, interpreting information, graphs and whatever else. Okay, but in terms of new skills, knowledge, understanding that you need to pick up, this idea of watts and kilowatt hours is important. Now I did actually, just up here, unit conversions are important as well. 1,000 watts to a kilowatt, 1,000 kilowatts to a megawatt. Okay, we don't measure many things around the home in megawatts. Your power bill will be, and when we say power bill, it should be an energy bill, talks about kilowatt hours usually. Now, taking these skills, let's have a look at another example here. If my electricity now is being charged at 41 cents per kilowatt hour, how much will it cost to run a 2,300 watt heater for 6 hours a day for 90 days? Okay, well, first of all, let's say 2,300 watts equals 2.3 kilowatts. Now my cost is going to be 2.3 times 0.41, right, don't forget the cents to dollars, times my 90 days equals, I'm going to pull up my calculator here. Let's drag this up. Come on, calculator. What are you doing? Here we go. 2.3 times 0.41 times 90 equals $84.87. Now, that's a reasonable sort of figure. If you think about that, 2,300 watt heater is not a massive heater. It'll certainly heat a reasonable sized room. 6 hours a day for 90 days, sort of over winter. Maybe running a heater in your bedroom at night time might cost you $90 over the 3 months of winter. Okay, not entirely unreasonable figures. Rightio, I'm going to look at 1203 in this video here too, because frankly we can, and there's just not that much extra there. I've introduced a couple of other units now, gigawatts and terawatts. A gigawatt's 1,000 megawatts, or 1,000,000 kilowatts, or 1,000,000,000 watts, and a terawatt is 1,000 gigawatts. Now, we're talking about sort of bigger figures now. Let's say I have a city of 250,000 people and they're using an average of 10 kilowatt hours per capita. So how much energy do they use per day? Right, it's going to be 250,000 times 10. Now this is going to give me an answer in kilowatt hours. So that is, of course, 2.5 million kilowatt hours. Righto. Now, which is, we could say that that is 2,500 megawatt hours, or it's 2.5 gigawatt hours. We tend not, anyway, gigawatt hours, possibly, or we might even say, we could say it's 2.5 by 10 to the power of, right, let's imagine this was watts, or watt hours, so I'm going to have 3 more zeros on the end here, so I've got to move my decimal place. 1, 2, 3, 4, 5, 6, 7, 8, 9. So by 10 to the power of 9 watts, watt hours, if we were to represent that in scientific notation. Rightio, I think that's going to do us for now. That's our, we've learnt what watts are, power and energy. So watts, watt hours, kilowatt hours, and how to perhaps calculate the cost of using that. Okay, thanks guys.